Hello, everybody. I'm very proud and pleased to be here with you today. I'm Celso Azevedo, one of the coordinators of the Technology Committee of the Chamber of Commerce Brasil-Canadá. The Chamber of Commerce Brasil-Canadá is an independent non-profit organization maintained by private sector that has been promoting since 1973 business, cultural, educational, and technological initiatives and projects between Brazil and Canada. Located in São Paulo and Montreal, it brings together people, companies, public and private institutions from various branches of activities in both countries. CCBC's services and products are tailor-made, modern, and innovative, providing visibility and networking to members in Brazil and Canada. CCBC has extensive experience in technology area, being one of our axes of work with a very active technology committee and holding several events in Brazil and Canada. CCBC promoted several missions taking Brazilian startups to Canada. We have partnerships with several accelerators. The Chamber is also in charge of several projects that promote startups, such as SP Tech Week, Canada House, and Elevator Pitch. The Technology Committee will be promoting various events this year, and we are starting with a very innovative one to talk about quantum computing with our special guests, Dr. Bruno Chagas, computational scientist at ICHEC, Eduardo Maschio, data engineer at QuTech, and Rafael Verissimo Martins, co-founder at Brasil Quantum. As you should know, quantum computing are cutting-edge technologies that are evolving very quickly and will change the way we will interact with the digital world in the near future. But I'm not the very one to talk about it. Let us hear from our experts. Please, Bruno, the microphone is yours. It's your turn to talk.
Hello, everyone. I'll share my screen right now. Let me see. Okay, that's great. Thank you for the organizer for inviting me. It's my pleasure to be here talking about the theme that I'm completely passionate about, that is quantum computing. And I will present a few slides about what I'm doing in quantum computation, what we are doing in Brazil about the quantum computation. And here, that's me, and the cities where I lived. And the first one is, my name is Bruno de Oliveira Chagas. I'm a Brazilian, and I did my graduation, the graduation in mathematics and the master's in computational modeling in a city called Volta Redonda, this one with this industry and this most around the city. And after that, I did my PhD in computational modeling, but I started doing numerical analysis for my master's and doing some Helmholtz equations, PDEs, and so on. And I moved to the Petrópolis, this city here, where we have the LNCC, the National Laboratory for Scientific Computing. And there I pursued my PhD, but I started in numerical analysis. But I did a course in fundamentals of classical computation, and we had a seminar, and I chose the quant computation to present to the students and the professor there. And it completely changed my life, and I jumped into the quantum computing, and I started a new area of research at the middle of the PhD. It was a crazy idea, but not so much, because I love this area. And after my PhD that I did on quant search problems on graphs, I went to Minas Gerais, the Federal University of Minas Gerais, to do a postdoc, being a postdoc researcher there. And I did some analysis and physical realizations in the IBM Q computer, but doing quantum walks, some algorithms, experiments, doing research with some students in master's, doctorate, and now I'm a computational scientist here in Ireland at the ICHEC. This stands for Irish Center for High-End Computing, but I'm developing some projects in computational chemistry here, and I'm loving the city and the research I am doing here. So that's me, and this is the stadium called Mineirão, where Brazil lost to Germany 7-1, unfortunately, but um, it is what it is, like the quantum mechanics. It is what it is. And what about quantum computing? So we need to give you a very gentle and quick explanation what's quantum computing. And we have a certain ingredients for the quantum computation and the quantum mechanics. Um, we have the duality of a particle. It is the wave particle duality. And we have this famous experiment called double slit experiment, or Young's double slit experiment. It is considered one of the most beautiful and spooky experiments in physics, because we can have an electron and we expect that the electron, in the classical point of view, being a particle, if this electron is a particle, we expect when the electron crosses the slit, we expect two vertical lines depending on the slit that the electron is crossing through. So, but that's not the reality of the nature. We see that if we don't observe, we don't measure here the slit, trying not to figure out where the electron is, we have this behavior. It is a wave behavior of the electron. So to be a wave behavior, we expect that the electron is crossing the left-hand side slit and the right-hand side slit at the same time. And it is interfering to itself, producing this wave behavior like this. So one of the main ingredients for the quantum computation, it is the interference pattern produced by the wave. Another ingredient for the quantum computation, it is the superposition. It's almost, we can have different states at the same time. Like you have to toss a coin, we can have heads and tail, but in the quantum sense, we can have heads and tails at the same time. It is very spooky, but it is the reality of the nature. This is a very known experiment, the Shrinkage Cat. We have a device that, simplifying the experiment, we have like an electron that points up and points down, and it is in superposition. If we open the box that the cat's inside, we'll see the cat, it is dead or alive, depending on the observing the electron if it's pointing up or down, because when we open the box, or we're trying to figure out where the electron is in the double slit, we see just one, not the superposition. Superposition, it is a quantum phenomenon. So the cat, for the Schrodinger's experiment, he's dead and alive if we don't open the box. It is like a zombie cat that it is dead and alive at the same time. And we have another ingredient for the quantum computation, that is the entanglement. The entanglement, imagine that we have a photon, and we call this a twin photon, and we can separate them, putting in a side of the galaxy and another side of the galaxy. And if I observe the electron in one point, we have a correlation between them, even they are separated from miles and miles away. That's completely strange to our classical sense. But the message here it is, imagine that we have several slits, but not two, not three, 100, 1,000. We can choose, we can have the electron crossing through every slit. In the algorithm or the evolution of a system that we want for the algorithm, it is, we want to construct a path that reinforces our solution. And we can have this using the superposition, using the interference pattern of the wave-particle duality, and entanglement. This is the main ingredient for the quantum algorithm. That is crucial for us. So the main quantum algorithm is the story of the quantum computation. It is the Shor's algorithm in 1995 that we can factorize certain numbers in prime factors. We believe that this kind of problem, it is very difficult to us, but using quantum algorithm, that is very easy. We can say that it's a polynomial time, it runs in polynomial time. We call this efficient algorithm. But the classical algorithm for the prime factorization, it is inefficient up to now because we don't know. We believe that is difficult. It was an outbreak for the computation in a general sense, because now we have an algorithm that factorizes certain numbers, and the cryptographic systems that we have, it's based on this hardness of this problem. And like the RSA protocol, we can break using the Shor's algorithm, but we have other techniques to tackle this problem. This is the post, I forgot the name, but it's when you have a system that we have attack from a quantum computer, we can manage this. Another algorithm that is the Grover's algorithm. Imagine that you have a database that we are searching for a certain number. And the worst case, using a classical algorithm, it runs proportional to the size of the list. If we have n elements inside the list, we need to see n times this list. But the Grover's algorithm runs in square root of the size of the list. We have a quadratic speed up using quantum algorithms. And these were the algorithms in 90s, but we have lots of like Deutschiosas, Bernstein, Vazirani, and other techniques that can build some quantum computation. But we have other algorithms, and they are very, very useful to our purposes in science in general. That is the quantum algorithm for solving linear systems. If you're dealing with numerical analysis, we end up using a Gaussian routine to solve our linear system. And we can have these using quantum algorithms. And we can have a speed up in quantum chemistry using quantum computation. And this is a paper in Nature 2010. And we can have a quantum machine learning. We have this paper by Lloyd, Mosseni, Hebentrust, and this is a very fresh area of research in quantum computation, that is quantum machine learning. So what about the Brazilian researchers? Because we are trying to connect the Canada and Brazil and trying to figure out what we are doing here in Brazil about the quantum computation. So my area of research, it is quantum walks. It is a strategy to find techniques to build some algorithms. They are very known, and we have a bunch of problems that we can solve using quantum walks. And we have these two researchers, Nissim Zaguri and Luis Davidovich, and they produce the quantum random walks, and they are Brazilians, together with Yakir Aharonov. It is the uncle of the Dorothy Aharonov, well-known research from quantum computation. And this is a paper from 1993. But as far as I remember, Nissim Zaguri and Luis Davidovich, back at the day, they were in Mexico or University of Mexico, I don't quite remember, but they are researchers in Rio de Janeiro, they are Brazilians. We have some others researchers like Renato Portugal. He was my advisor in National Laboratory for Scientific Computing at my PhD. He's known for this, to my opinion, and I'm completely biased to say that this is the best book for quantum walks and search algorithms if you want to study a little more. He has a lot of papers on quantum walks and other techniques. He's a very clever guy and can guide you if you want to pursue a PhD. Franklin Marquezino, he is currently in Federal University of Rio de Janeiro. He was advised by Renato Portugal. And this is a paper called the QuTech simulator. It was, as far as I remember, the first simulator for quantum walks in 2008. And he's currently researching in quantum walks as well. And Gabriel Coutinho at the Federal University of Minas Gerais. He was my supervisor at the postdoc. He studied in Waterloo in Canada, advised by Chris Godzio, one of the best mathematicians, computational scientists in some aspects of the algebraic schemes and techniques in graph theory. And most part of the research of Gabriel Coutinho, it is in perfect state transfer. He has a lot of results using quantum walks, considering the continuous time quantum walk. We have a lot of other research like Marcelo Terra Cunha and Bárbara Amaral. Bárbara Amaral was advised by Marcelo Terra Cunha. I think it was in UFMG, this Federal University of Minas Gerais. And they work more into the quantum information theory, in contextuality, entanglement, and coherence, and things like that. Ernesto Galvão at the Fluminense Federal University. He works on certain parts of the quantum information theory. We have this paper, this is the discrete Wigner function and quantum computational speedup, because we have algorithms and techniques we want to search for the complexity of the algorithm. And this is a technique using Wigner functions. And he's a collaborator in Portugal in a laboratory there. And we have Fernando Brandão, probably the most famous Brazilian at the QuTech, because he was one of the researchers in this paper that state the quantum supremacy in Nature 2019. André Carvalho, it is in the QControl, a company for quantum computation using techniques to error correction. And we have Raqueline Santos at the University of Latvia that was advised by Renato Portugal as well, working in quantum walks. That's all I have for today, and muito obrigado. Thank you for the invitation and for having me here. And that's all. Thank you.
Very interesting, Bruno. Oh, I would like to thank you for all this information. And now let us hear Eduardo Maschio. He will tell us about his practical experiences in Netherlands. Eduardo, please.
Hello, everyone. Thank you for having me. So I would like to share some of my insights in quantum computing and also in this very brand new area that we have, not only academics, but also startups and big companies trying to make it happen. Currently, we have initiatives from all the world trying to achieve some significant quantum computing technology breakouts. So I would like to show some of the recent achievements from the perspective of the Canada, Europe, and talk a little bit about China as well, and maybe offer some perspective on how to understand this scenario from investment and strategy perspective. So I will share my screen. Okay. So, okay. We have this very interesting field that it's growing fast. I think that we can say it all started on 2000 when it was one of the first discoveries of the quantum properties that could be used for superconducting qubits, which are a type of quantum bit for processing information. So it was a very important one because we could use the same process that we used to make the semiconductors from the computers that we use nowadays to produce this kind of new technology without so much effort on that. And we have these 20 years of advancements that I could say that we jumped maybe 50 years looking behind when you compare it to when you compare it to classical computing. The same time period that we took to advance in computation before. It was really fast on the quantum computing. So to everyone that would be interested in my profile, there is this QuTech page that you can access. I'm not going to show or to talk about that, but you can just check that. I can also provide the link later. But basically, I'm currently working at QuTech, and we are developing these topological qubits together with the Microsoft Quantum Lab here in the Netherlands. And there are also many other initiatives like the Quantum Internet that is the one that I think it's the most advanced and promising technologies that we are going to see in the next 10 years. So I'd like to present first the quantum scenario in Canada. There are some universities that I could find information of either some groups working with quantum technologies directly or establishing some institutes for quantum research. So basically, I found these three universities. They are very famous in the quantum scenario. So uh, whichever university you have nearby, it should be really um, worth visiting because they have enough structure and people to uh, guide your company or your idea to make it happen. So talking about also companies, you have many important companies. You can see D-Wave Systems. They are the very first one company that actually claimed to have achieved a quantum computing um, algorithm in 2007 or 2008. And it was really a groundbreaking for the field because you could start developing new algorithms or new techniques to make it scale up. So they have developed this technology to achieve more qubits since then. But because they use a different approach from the other companies, you can usually see maybe not too much news from this company, but they are the very first ones that claim that. You also have Xanadu, one of the most important startups from quantum uh, information perspective, also based in Canada. They work with photonics, so they have this also brand new approach on using unique photons to produce some quantum computation on a integrated circuit. Um, so basically, they provide this approach that should be scalable enough for larger circuits, and you don't have to provide very cold temperatures in order to make it work properly. They are they are very robust on that sense. Um, Agnostic, it's a quantum software mostly company. They are trying to provide some platforms and quantum software applications. So very interesting as well. Protein Cure, it's a very interesting because they are trying to develop new ways to provide new chemicals or compounds to pharmaceutical companies, as well as be quantum. And Anion Systems also, it's developing scalable quantum computers. I think it's they are using the regular superconducting qubits, the same that most of the companies are using today. But it's very different from Brazil, at least when you are in Brazil. It's different to see how companies are integrated with universities. For that to happen, you must have some kind of institutes behind it, trying to tie together those opposite initiatives. Because universities tend to have more research focus, not more on applications. And companies do need to work with applications and um, some kind of revenue-based development. So you should focus also on these uh, ties to make happen all those initiatives. And that's why we have many um, of them in Canada. So the first one, I think it's the most common and most recognizable. The Creative Destruction Lab, it's a accelerator that it's basically 2-year program that you can apply, you being a startup or a single person with some skills that would like to have the opportunity on a startup, quantum startup. And they work together with the academics to make it happen from the research and theoretical perspective to establish a good background on that, and also to provide some funding and also human resources to make a ER endeavor to skyrocket, basically. Together with it, you have many other institutes and funds. Mostly they are coming from the universities, um, and they are all supported by the Canadian government. And that's one of the very interesting difference that I see in Canada compared to Brazil, because you have the government basically trying to facilitate those approaches between the industry and the academia to make that happen. But the government is not the one that will uh, produce it by itself. So it's just organize the links between those parties. And from these 5 last years, for what I could see, the Canada government have invested this amount, has invested over 300 million Canadian dollars in quantum initiatives. And that's a big deal because they consider it that quantum information is a national security issue. So you have to provide enough funding and enough technological security to establish your own autonomy, and you can develop your own products and technology to not be um, held by any other country that could have that and take some advantage, strategic or maybe commercial advantage on your side. Most countries are interested also in the military advantage. So that's one of the reasons that they are investing so much on this yet to be uh, uh, produced uh, quantum applications and hardwares. And also, in another sense, you have the companies going after their funds independently by funds, private funds or international funds, mostly like VCs, or yeah, mostly likely. And yeah, they received about 200 million Canadian dollars in the last 5 years as well. So it's a very substantial quantity that they are investing in Canada, and it's comparable to many huge countries as well, or even the European Union. But it's not that much that they are investing compared to the overall. So the scenario in in European Union is a very solid one. So we have a quantum flagship and Horizon 2020. Most of them are basically injecting a huge quantity of money throughout the period of 10 years in the European Union countries, and also in some partnerships that I will talk later. But basically, we have a handful of companies from startups to universities, institutes, ranging from the hardware to the software. So it's a pretty solid and well-organized uh, scenario that you can rely on and you can start investing on. Canada by itself, I don't think it's that well organized, but well, it's not a union of countries, so it's expected to have less organization on that side. But by the contrast, it has a lot of partnerships with other countries like United States and also uh, the European Union, so they can rely on some relationships to establish some independence of uh, technologies they have or they would like to develop as well. So European Union has this quantum flagship that currently tend to invest 1 billion euros over 10 years in quantum technologies. It's important to say that this 1 billion is actually 1 trillion for converting for short scale billion. So it's 10 to the power of 12, not 10 to the power of 9. So in US and Canadian terms, it should be 1 trillion euros. And the Netherlands, for instance, has just announced this investment of 600 million euros at this Quantum Delta. It's a accelerator here that many of the quantum startups and companies are located in. So they are truly investing and providing a good um, background for every company and investor to make their part on this initiative. And for the last part, the quantum scenario in China, it's very unknown due to its very closed way to deal with transparency on investments. But we expect to have tens of billions of dollars at least to be invested for the next 10 years. Just an example that was uncovered recently, 2 years ago. There is this over $10 billion investment on this single center. So it's just a center there. They invested that amount and it's related with quantum information sciences. So it's very broad, but even though it's a huge amount of investment. And also they are bringing applications and developments at a fast pace. We can see on that picture that they also have recently uncovered that development of a quantum network through all this, I should say, east coast of China mostly. So it interconnects many big cities in metropolitan regions in China, and also some long-range distance using satellites. So it's a huge achievement, and it was most likely to be hidden from the public, or at least for the Western countries. So we just came to uh, know about that recently. So it's a big threat, and looking at the perspective of supremacy, technological supremacy, we don't know what they are achieving, so they just release some big achievements at once. Just a quick summary. Um, it was a information from a website 2016 about the UK government investing hundreds of millions of sterlings on quantum technologies. Also, the 1 billion euro investment on European Union countries. The Congress and US Congress also has developed founded this law that I don't think it's law, but this legislation that required to expand the budget for quantum technologies, such research or either research or education of $1.3 billion. There are other many initiatives from the government of the United States that are not related with the Senate, but they also have invested huge amounts of money on that, mostly like to be in the same amount, in the same order of investment. So also China on this 10 billion investment, $10 billion investment on this unique, only one national laboratory. So we are hoping to see more investments from China yet to come, and they are very aggressive on that. Also, it is reported to the quantum technology to grow fast and to grow its market very robustly. I think that even now that we have such scenario of quantum communications communications happening throughout the internet using Zoom or using other platforms. So you have to be very aware of hackings and attacks. So they are investing pretty much on quantum technologies to avoid that kind of attacks. So a perspective, quantum technologies in Canada, it's a national security issue. Canada and USA have this strategic alliance on quantum information security. It's a very important alliance that they established recently. And also Canada and European Union developed this strategic alliance to quantum technologies in general. So you can, there are many technologies that are currently being made here in QuTech and also in the University of Waterloo that they share common interests. And you can see that China is developing its own ecosystem and may cause a huge impact on the industry. So because of that, we have to the countries to be united and avoid the supremacy of a single country, because it's important to establish a very secure standard and avoid the gap between technological advantages between countries. So yeah, that's all I would like to show you. Thank you. Thank you,
Okay,
Celso.
Eduardo. Thank you. Oh, it's very interesting too. Oh, well, and I'm here wondering about quantum supremacy, but we will talk about it later. Well, last but not least, I would like to ask to Rafael to say what is happening in Brazil about this topic and tell us what is Brazil Quantum. Rafael, please feel free.
Thank you, Celso. Just one moment. Can you see my screen?
Yes.
Okay, perfect. So first of all, I would like to say hello to everyone. I would like to say thank you for the whole team for the invitation. It's a pleasure to be here to talk about this topic that is so important. So my name is Rafael Verissimo. I'm a former student of engineering at Military Institute of Engineering in Rio de Janeiro. And I'm currently doing my master's degree in France at the Institut Polytechnique de Paris. Also in France, I had the opportunity last year to work at Capgemini on a quantum computing group in the Paris office. And I'm the co-founder of Brasil Quantum. That's the Brazilian initiative that aims to improve the quantum technology ecosystem in Brazil. So I would like to complete what Eduardo and Bruno have said by highlighting some aspects regarding the development of quantum technologies here in Brazil and how this relates to what we are doing at Brasil Quantum. Initially, due to the experience that the founders, including me, had abroad, we realized that Brazil could not afford to be left behind in the development of quantum technologies and quantum computing. All around the world, governments and companies have been investing heavily in the development of this kind of technology and preparing people to work in this area. So with this in mind, Brasil Quantum was born last year in the middle of 2020 as the first quantum computing initiative in Brazil. So at first, our projects were very focused on the dissemination and training in the subject, but looking to the, so this is the Brazil Quantum team. So we are 5 people that started the project last year, and looking to the whole context in Brazil, we understood that focus on dissemination and training would not be enough. So Brazil is among the 10 countries that invest the most in research and development in absolute terms. So although in terms of percentage of our GPD, this investment is smaller than it should be, Brazil is still one of the most, the countries that invest the most in research and development. And in addition, Brazil has a relevant scientific production figuring in 12 according to the World Bank in 2016. In terms of production of scientific and technical articles. And it has also been ranked among the 30 most creative countries in the world by the Martin Prosperity Institute. And yet, when you look at our innovation, Brazil figures very poorly. So having ranked in 66 in the global innovation ranks in 2019, and probably when we look at our level of competitiveness, that scenario is even worse. So in contrast, this contrast or the reason why this difference, these investments and knowledges do not turn into innovation and solutions that improve the people's life here in Brazil is mainly due to three reasons. So the first one is the misuse of resources. So mainly due to the lack of long-term vision for the country's technological development. The second one is the bureaucratic difficulty to start a business in Brazil or doing business in Brazil. Everyone that have started a business here knows about this. And this relates to the last aspect, which is the lack of connection between companies and universities, mainly because the bureaucratic relation is very difficult. So looking at this scenario, we understood that our mission is to accelerate and boost the Brazilian ecosystem of quantum technology as a whole. And we are doing this by working mainly on three fronts. Working in partnerships with industry is the first one. Working in partnership with those that do research, such as laboratories and universities. And last of those is preparing people to take on the opportunities that we are creating here in Brazil in the area of quantum computing. So we are trying to work on these three fronts to boost the ecosystem here in Brazil. And we know about other startups that have started their work here in Brazil, like one startup from Santa Catarina in Florianopolis that started, I think, 2 years ago, but by lack of investment and lack of work on this area for develop this kind of startups here, they had difficulties to keep on this activity. And we know about another startup in São Carlos, that is a city in São Paulo, that works on this area. And Brasil Quantum wants to improve this ecosystem so we can have more startups and more research on the area here. And commenting a bit on our initiatives, Brasil Quantum already has some important partners in Brazil, with some new ones coming soon. In the area of education, Brasil Quantum has partners, has partnered with companies such as QuTech, which is British, to provide an introduction course on quantum computing that I will talk a little bit about later. And another one is the I2A2, which is a Brazilian-Canadian company, Microsoft, the Central Bank of Brazil, and Klabin. So talking a little bit more about our educational programs, we are working with I2A2 on a quantum machine learning program for the formation of a new quantum workforce. That's an international course that will be released soon, focus mainly on this area. As I said it before, I2A2 is a Brazilian-Canadian country based in Canada. The other one is QuTech, which is a course on Portuguese of introduction for quantum computing. It's not yet in the site, but it will be soon. And furthermore, about other projects that we have a project with Klabin, which is the largest paper producer and exporter in Brazil, and on the first quantum computer internship in Brazil, aimed at the industrial optimization applications. So optimization is one of the most promising areas of quantum computing, and some projects are already being tested all around the world. One example is the project done in Dubai in partnership between Microsoft and Dubai Electricity, if I remember well, to optimize the use and management of smart grids. So this area of optimization is very interesting, and we are doing a project in that with Microsoft. The other one is post-quantum, a project in post-quantum cryptography in partnership with the Central Bank of Brazil and Microsoft, which aims to understand what methods of post-quantum cryptography could be adapted for the PIX, which is the central bank's instant payment system that allows instant transactions 24 hours a day, 7 days a week for the Brazilian financial service. So this project is mainly focused on the algorithms that are in the Nist competition. So Nist is a US Department for Standards, and they started in 2017 a project, a competition to define what's the new standard for post-quantum cryptography. and this work is mainly based on this kind of algorithms. It's a really interesting program, and this area of cryptography is a area that's very important. Is of strategic importance for all countries, as Eduardo have said a little bit before. And this is one project that we are doing here in Brazil that is very innovative. With all this said, I would like to complete by saying that Brazil has extremely skilled and qualified people in the area, as Bruno have showed before. And besides, it has a huge market for quantum computing applications, like in Klabin, like in other industries that we are talking to. And companies are interested in this kind of applications here in Brazil. With that said, we need to connect those interest parts with people that are interested in this technology, connect universities and companies, and try to create an ecosystem that's more friendly for those who want to develop this kind of technology here in Brazil, and also invest time and money to the development of this ecosystem here that, in my opinion, is very, very promising. So that's all. Muito obrigado. Thank you for having me here. And so let's go to the questions now.
Okay, thank you, Rafael. It's amazing, and I can see it's a huge amount of work you are doing. I think it's very admirable the work Brazil Quantum is doing today. Well, let's go to our audience questions. The first one is from Fabio Costa. He says, "Hello. How to begin in this field of quantum computing? What is your advice to study?" Well, Rafael, you said one of the objectives of Brazil Quantum is to work in the learning field. Can you answer this one?
Yeah, sure. I would like to ask Bruno also to complete my answer, because I know he is very into educational materials, but I can start, of course. So there is a lot of courses on quantum computing, the internet. So I can remember some right now as the Prescue. There's a professor from QuTech that's online on YouTube. That's an excellent course. We have more introductory courses, both on Coursera from, I think, St. Petersburg University, and on EduX, that is another MOOC platform from QuTech, that I think is where Eduardo is. So these are some courses that you can take online in form of video, but also you can find material in form of books. There is some well-known books to get started in the field. So one that is more mathematical, but is more introduction for quantum computing, is the Quantum Computing Explained. I don't remember the name of the author right now. I think it's Mac something. I don't remember right now. There is one book that's very well known in the quantum computing community. That's the Nielsen books. That is called Quantum Computing. Is kind of the Bible for quantum computing, but it's a very big book. So, but it's a very good material also to learn about quantum computing. And
Okay.
last, there's a book that is very interesting and very nice to read. That is Quantum Computing Since Democritus from Scott Anderson. That is a professor in Texas, if I'm not mistaken.
Oh, very good. Eduardo, Bruno, you can now open your cameras, and if you have something else to add to what
Yeah, sure.
Rafael said, please?
Rafael said the most known books from quantum computing, like the Scott Aronson's books, Quantum Computing Since Democritus, that is some good explanations that goes back up to the Greek philosophy, and he is a very clever guy, and he writes very well. This is a good starting point, just avoiding some calculations, but I think it depends completely on your background. If you have a more mathematical background, I suppose a good starting point it is the quantum computer explained from McMahon, because there is a bunch of mathematical objects that we can work on, but it is not exhaustive, an exhaustive book. This is a Nielsen's book, Quantum Computation. It is most like to have this book if you go to a desert island. If you can bring with yourself just one book, probably this is the Bible of the quantum computation, because we can have quantum algorithms, quantum information, physical realization, but it is not updated about the physical realizations. But if you have a mathematical background, you can go with several books, but you can have a background more in computing, working in some languages. You just need a certain notions of the mathematics and the physics, and probably Eduardo can say more about that if you're gonna be a software engineer or a quantum software developer. We have some programs for graduation in Brazil. If you want to, we have in Rio de Janeiro, the LNCC, the Federal University of Rio de Janeiro, and we can talk to me. You can send me an email. I can send you some material, some devices, and so on, because it is at a very short amount of time to say everything about quantum computing and devices like that. But Eduardo can say more about the quantum software engineer part, probably.
Yeah, I'd like to send a link for the EDX courses on quantum computing. There are a bunch of um, either one of them are good enough to at least get this start pointing to understand what is needed to have and what is needed to develop in order to learn and to apply quantum computing on your um, problems. Um, I don't know if I can say that, but there should be some courses going to happen soon. So maybe you can stay tuned and we can keep contact. And yeah, basically, I think that the most important part is to um, have contact, have um, the first interaction with the tools or the ideas. So there is this very famous, you can say, quantum programming language that it's from IBM. It's called QuTech. They have a very nice range of examples and how to use the the algorithms. It's not ideal, but you can get a feeling of what it is to have your hands on quantum computers. So yeah, feel free to talk to us later if you to like to have more information.
Okay. Well, let's go to the second question. It is from Reinaldo Buria. And I think Rafael said something about it. The question is, how are the researches in this area being applied to a smart grid environment? Oh, anyone could answer this?
Yeah, as I said it, I know about a project in Dubai with partnership with Microsoft that were on optimization for the management and use of energy in smart grids. But for be uh, I don't understand very much about energy grids and smart grids. So is the only project that I can remember. But sure, there is applications in the area. I think quantum computing is a very transverse area, so it can be applied in a very wide range of areas. So I'm sure that there are some applications in smart grid environment.
Okay, thank you. Uh, the third question from Gustavo Schelles. Hi, I don't belong to the quantum computing area, but I'm very curious. I heard that it's possible to run programs in some quantum computer prototypes, mainly in the USA. In which kind of language are those software written so that they can run in those prototypes? Is there a standard of instructions being born? Oh, I think this one is to Bruno or Eduardo.
Yeah, most part of the language that we can work with quantum computing is based on and written in Python, like the QuTech. That it is a software kit development. It's a kit for development in written in Python. We have some routines. You just need to know a little about quantum computation and Python to work with this language. We have Penlane written in Python. We have Tequila. It is a new language that we can work in quantum chemistry and machine learning. We have Q Sharp. This is from Microsoft. It's more a language than a package. We have a lot of language. We have Circ. It is another language. And we can run using some backends from IBM. It is totally free to use those backends. We have several other backends like from Rigetti, IonQ that we can use. If you want to start programming in a quantum computer, I would suggest you to work in Python and have some basic courses in Python to work in quantum computation. It is my advice. Probably Eduardo have a few words to say about quantum computation as well.
Yeah. Well, mostly you have to understand quantum computing, or at least to learn in while you are learning the language as well, because they vary very much. So there is not a standard or a common language right now, but there's this thing that you can have. Um, it's a platform. Let me check here. It's a platform that you basically can um, use any language you'd like and run on any computer you want to. So different quantum computers have different requirements to be run quantum algorithms. So yeah, it's right now we are just living in the beginnings of the 50s, where each computer is very unique. So you have to build a unique solution or unique algorithm or unique language to deal with that. We are still a little far away from defining a common language. But as Bruno said, you can choose one of those nice languages. Maybe Qiskit is the easiest to learn because if it's well documented, and yeah, maybe that's one of the favorite from people.
Okay. There's another question. Let me see here. There are no hackathons and competitions in quantum computing or hands-on programs to flow in the area?
Yeah, there is some hackathons. I participated into the Code Forces. If you know the Code Forces, it is very known to marathon in classical computing. And I participated in these Code Forces using the Q# language. And I conducted a team of Brazilians. We achieved the second and third places among the Brazilians in this competition. It is a very good one to work on some basic stuff in quantum computation. And we have some hackathons from IBM, but it's more into challenges. And we're gonna have another one that is like a summer school in quantum machine learning. And I suggest you to look at that because it will be very, very nice to follow those courses. And about some hackathons and hands-on programs. Probably you're gonna see the Qiskit and IBM platform some good material to follow and to study quantum computation. Probably, as Eduardo said, it is the best starting point to work on quantum computation.
Okay.
I have one comment also.
Yes, please.
You can find some hackathons. But there is also this foundation. It's very interesting. Maybe it's for people with a little more knowledge on the field, but anyway, it's very interesting to see what's happening and what people are looking for. So we have this quantum foundation, very interesting. Yes.
Okay. Okay. Well, another question. This one from Carlos Eduardo Palladini. Does anybody have some information about quantum computing at India?
Yeah, there is some groups in India working together with IBM. They have some meetings. I forget about the name. Probably it is like IndyQ, something like that. In the last global challenge, we had a lot of Indians working some projects, studying with the people. They are very interested in quantum computation. They are running with us into these projects. I just know about this group. It is something like IndyQ, something like that. We can search in Twitter. Probably you're gonna find them.
Okay. Okay.
Yeah. If I'm not mistaken, I think Rodrigo, that's one of the members of Brazil Quantum. He's part of this study group in India. I don't know why, but I'm pretty sure that he is in the group. So if you want to know about, you can also send me a message or someone, and we can find the group.
Okay. Thank you, Rafael. Uh, Another question. Uh, the current cryptography we use today will be affected by quantum computing. How do you see this? It's the end of cryptographic systems. Bitcoin will be killed and crypto coins.
I think it's not because, as we said here, some protocols in classical sense of the cryptographic system based on RSA, and we can break using Shor's algorithm, but it's just a part of the cryptographic system. But we have a post-cryptography technique that we can have a classical computer that we attacks with a quantum computer. We have some techniques to deal with this type of attack. And up to now, it is safe even with shards, but shards can break the RSA, for example, and some other protocols. But it is not a tragedy using quantum computation, but we can be careful using some new techniques as we said in the history of the humankind.
Okay. Well, another one. We can see different approaches in quantum computing. Some of them based on semiconductors and other based on photonics. One of these technologies will prosper or all of them will coexist. Eduardo, I made this question to you
Yeah,
in the
that's a great
past.
question. I think that we have a lot of space to permit any kind of hardware development right now. It's up to the uh, actually it's up to solve three problems. One is scalability. Another one is to make the qubits reliable enough to provide reliable computation. And the last one is how cheap it can go. It can go when you scale up. So maybe in the future we will see some kind of hybrid systems, maybe having a trapped ion quantum processor with some superconducting buses going to the uh, diamond quantum memory and then passing to another computer using photonics. I think it's a great way to take the best part of each technology and hardware and combine them into most efficient machines.
Okay, okay. There is another question from Ana Franco. Companies like IBM, Microsoft, and Google are racing to build reliable quantum computers. In your opinion, which one is winning the race? Good question. Oh,
Well,
I think
I can say that none is winning because you have to solve the problem now that is um, you have a physical qubit that is you pick some kind of hardware and make it process quantum bits. So you can basically say that it's a qubit or a quantum bit, and then you can scale these and say that it's a quantum processor. You can do this with several hardwares or systems, physical systems, but one physical qubit is not enough to secure the amount of reliability that we need on the quantum processing in order to have a quantum computer fully working. So basically, using the current technology, will need by 1,000 physical qubits to encode one single logical qubit. So with this one single qubit, logical qubit, we can in fact have all those security and reliability and feasibility to provide a good quantum computation. So in fact, we have to scale up much more than we are currently doing now. Microsoft's attempt to provide these topological quantum computers basically is trying to um, lower this upper bound. So instead of having 1000 qubits, physical qubits to provide one logical qubit, you can basically provide with 10 physical qubits for one logical qubit. So it's a huge difference and it will make it easier to scale up. But there is no actual quantum computer using this topological yet. So yeah, let's see how it goes on the next 2 to 5 years.
Okay. Another question. I think this one will be best tailored for to Bruno. Today, there are already great advances in range of probability. As for the manipulation of qubits, is quantum superposition already a dominated practice?
I didn't understand quite well about the question itself, about the superposition.
Yeah, he's asking if we are manipulating correctly quantum superposition.
Yeah, we have superposition inside those computers, but maybe the problem that we can address is about the physical qubit and the logical qubit is a huge difference because, as Eduardo said, we need 1,000 qubits to have a one logical qubit, like the Shor's algorithm. To break RSA, you need 1,000 logical qubits, and for one qubit physical, for one logical, we're gonna have 1,000 others to build this one logical. Probably the roadmap for the quantum computation, we need 1,000,000 physical qubits to run Shor's algorithm to break RSA. So it's a very, very long road to achieve a practical usage of the Shor's algorithm and other algorithms. So, but we have superposition inside those computers. We can transform, making entanglements and so on. We have all the features inside the quantum computation, but we have the problems of with the coherence, that it is almost saying that the nature of quantum mechanics trying to relax and going to the ground state more relaxed, going to a more classical point of view. Yeah, something like that. But it is a very long road up to a very full purpose quantum computation.
Okay. I think, well, we have 2 minutes before our time ends. So I would like to thank you. And if anyone wants to make his last words, please feel free. Rafael, Bruno, Eduardo.
So I would just like to thank you for the opportunity. I think it's very important that we have this kind of discussion and kind of event. That this is very important to create and develop the ecosystem and the ecosystem for quantum technologies, and have the opportunity to think about working together between the work projects together between Brazil and Canada, and I think is a very good initiative.
Okay. Bruno, your last words?
Yeah, I would like to thank you for the invitation, for having me here into this event. And it is great to talk about this topic that I'm completely passionate about, this, the quantum computation. And it's a pleasure to be here, and feel free to contact me, send me an email asking for some advices and what we can do about quantum computation inside Brazil. And yeah, that's all for me. Thank you very much.
Okay. Eduardo?
Yeah, I'd like to say that if we have to keep up with this technology, we have to start now. We still have time to develop it. Um, so it's a call for all the entrepreneurs and the companies that are present here to understand the importance of this technology that will eventually come in this decade. So I truly ask you for considering this opportunity to make it happen until it's too late and you are behind all of the competitions or all of other companies around the world. So yeah, it's a important call for action right now. So thank you for this presentation and for everyone that enjoyed it. And I hope to see you again.
Okay. Oh, well, I would like to thank our speakers for the high quality debate we have here today. And of course, everyone who attended our meeting. Please don't forget to follow the next actions, the Technology Committee of Chamber of Commerce of Brazil, Canada. So that's all. Thank you, everybody.